Good day to everybody. Thank you for joining me today and all my awesome subscribers. Today's topic, wait, do you guys hear that?
11 frames.
11 frames.
11 frames. 11 frames. 11 frames. 11 frames.
I think everybody has realized and heard somewhere 11 frames somewhere on the internet by now. Well, I thought it'd be a good idea to actually make a video of this explaining the ins and outs and, well, what nonsense it is. Let's first start off with me showing my actual video. Let's do that. Funny enough, this is still one of my favorite intros that I have made throughout my YouTube channel.
Ignition sequence start. 6, 5, 4, 3, 2, 1.
Unfortunately, I will be taking the original song off because of people trying to copyright strike me the last time with it. The original video will be in the link below if you want to watch it with the original soundtrack. Tell me again how I did not show all the frames in the video. Weird, eh? Right, so this is the place you must start paying attention. You see, I'm just sorting out, showing you where the inferior mirage is starting, the top of it. You can clearly see it's an inferior mirage. Okay, it's optical. Anyway, as it goes on, I take the line away, you still see the inferior mirage. Let's see where the impact point is. Oh, wow, where was the impact point? Remember, folks, I took the inferior mirage out. You know, the thing that doesn't show. So it's literally just taking out that delay. In other words, the impact point is on the horizon, not behind the horizon. Let's take a closer look at that. Okay, but let's first see, I'm showing the original without taking frames out. Can you see it's actually vanished into the mirage if you look at it slowly? So there we go, it vanishes, you see, so that little piece that's where it vanished into the mirage is what I took out. So this makes a person wonder, why for the last 2.5-3 years have I been getting people telling me, you've been dishonest, you've removed 11 frames that took the curve away. Now, you got two problems there. First of all, can you even count the frames? Because it's definitely not 11. And secondly, since when is the inferior mirage curve? So this is a question to all you people, the people that claim I removed curve somehow. So are you claiming that inferior mirage is not optical, but the physical curve that you call your horizon? Please someone answer that, anybody. But anyway, let's move on to an awesome rendition to work out how much frames it was from RoughMoose. So it's so simple to see. The mirage was just optical, and that what was blocking the capsule, it didn't go behind the curve. Now if you're claiming I removed those 3 frames, which is Earth curve, you're claiming that your horizon is not physical. Get it? And again, 3 is far away from 11. You think that's all? No. Let's hear from your great messiah, Ranty.
Let's get some things straight. So, wherever there's an inferior mirage, we always get this stretching going on. There's always a stretch going on. Doesn't matter where you go, it always stretches near the horizon or the perceived horizon. Now, this is quite evident in this particular image of this lighthouse. Let me just get the shape up. So if I put a line through from there to there, which is where the chimneys are, for instance, you'll see that it retains its aspect ratio on the width.
Yes, remember the days when Ranty actually knew what an inferior mirage was. Now he just ignores it, actually.
But when we scroll that to the top of the chimneys there, and then we put another one to the top of the chimneys here, let's just do that correctly, and then we do it from the top of the lighthouse down. Now what you'll see is when I now measure this same part here and place it from the top of the chimney down, can you see how stretched it is in compared to the top of the chimney pots?
Yes, can you see the stretch? All optical, in other words, not like what is punting today, everything is physical.
So we always know that we get this stretching effect going on right around here. So in order to avoid that, what we have to do is exclude the frames that are closest, well, the frame closest to the inferior mirage. Now, let's go back to the image.
Yes, folks, Ranty is the king of rulers on screens. Be it very apparent to you.
What I've done here is I've gone through this frame by frame, and as you can see, I've now put the next 4 images in, 1, 2, 3, 4, and what I've done is I've scaled the first one to line up with the number 10. The bottom of this is at number 10.
See, he was actually quite thorough those days, putting actual frames to actual rulers and with actual some sort of measurements.
So that what I'll do is I'll count 1, 2, 3, 4, and I'll know how far this has traveled over 4 frames, and then I'll be able to run it back and get a calculation. So in order to do that, next frame, here we go. So I've put these lines in. Now, as you can see, first one is scaled directly on the number 10. And then we've got 1, 2, 3, 4. Hi, Del. Nice to see you in. Nice to see you in CGI Ranty and National Memorial Gardens, is it? Yep. So these 4 frames consist of 4.3 millimeters on this.
No, Ranty, actually that's 5.3, not 4.3, but okay. Everyone makes mistakes.
This ruler. So all of these are fitting inside 4.3 millimeters. Or is it 5.3? 5.3, my mistake, 5.3. So 1, 2, 3, 4, 5, 5.3 millimeters. In the next frame, so this is where we're going to get a little bit of stretching going on towards the bottom. This very last image here is going to be slightly stretched.
Correct, because that's where the inferior mirage is situated. You know, the optical mirage, not physical mirage.
Even though we do have a definitive center point, it is still going to be stretched on the top image. So we're going to take obviously references from here, but this is the last 3 frames. 1, 2, 3, 1. Then we get an inferior mirage. Then we get another inferior mirage, and you can clearly see on the next frame where we're going to end up with this inferior mirage line. So let's zoom in, and we've put the inferior mirage line in right through the center, and it ends up at essentially 1.2 millimeters above the perceived horizon.
So in other words, it is very, very close to the apparent horizon. Thus it will have an instant splash.
Right, so now that we've got the trajectory of the object falling down, let's get the next stuff in. Now, what's interesting on this, now I'm sure if Rheds or Slice Barcane does this, they'll also see the same effect happening here. But the inferior mirage actually happens slightly lower down. So it's actually saying that the inferior mirage of the splash is actually slightly nearer than the trajectory of this object that was falling. So that tells me that in some way this object as it was falling was actually coming slightly nearer towards us. It's actually working its way towards us, and the splash was being pushed slightly this way.
Interesting. So the capsule is further, but it came to trajectory closer towards us.
Which you'll see on the next frame. You'll see that on the inferior mirage. Now, I noticed this morning when I did it, and I got the same effect when I repeated the same on this. And that's that the inferior mirage is slightly lower down. And that tells me that the inferior, whatever this splash is slightly nearer than where the object was coming down this way. And that's been demonstrated loads of times by me over the past. If the inferior mirage is lower down, it's slightly nearer.
This is a great point, Ranty, because based on you guys saying with physical Earth curve these days, so the smaller the inferior mirage, the lower it is, the closer the inferior mirage is. So that means if we see blockage from a wave, this inferior mirage is actually just pushing up the limited angle.
Hi Brian, nice to see you in. So anyway, so now we've got some details here. We've got 4 frames going along here above this point, and we've got all these 4 frames going down here. What I've done is I've eliminated frame 1, which is this one, where we're going to get that stretching going to happen as showed and demonstrated here, what happens with this stretching. And what we're going to do is we're going to measure the distance between these 4 frames here on the splash.
Okay, cool. So you've already set the frames for the falling and now the frames for the splash coming up.
Right. So we've got from 2.1 to just over 5.05. So that's the difference. That's how much the splash has taken up over 4 frames. Right, so let's put them on so that you can see that. So 5.3 millimeters is the distance that these 4 frames have traveled on the object falling, and the splash has returned 2.95 over these 4 frames. Right, so that's the splash going back up, much slower, much faster going down, much slower going back up.
Great, I think it's making sense so far. Are you all following? Thank you, Ranty. Do carry on.
So I'm trying to figure this out. I'm trying to think, well, what would, well, obviously I'll give you the results in a minute, but what would be the ideal circumstance to get a result where we would get this? And the only way I can figure it is this. So we've got 5.3 divided by 4 equals 1.325. So that means that it is traveling 13.25 millimeters every frame down. And then the splash going up is 2.95 divided by 4 equals 0.737. So that's 7.37 millimeters going up. Right, so it's almost half as slow, but not quite.
Yep, as Ranty likes to say, the maths doesn't lie. So, go on.
And let's go to the next frame. So the next frame is really interesting, actually. So what I've done is I've taken out the last clear image that we had of this, tumbling capsule. So as it's been tumbling along, I've taken this screenshot of this and I've placed it along here because we know that there's the top of the capsule. There's the top of the capsule. So we can get a rough idea of pretty much where this is actually going to be in relation behind the inferior mirage. Now what that does is it places it about 4.2 millimeters or so above the actual horizon, something like that. So it's very close, very, very close. In actual fact, if you're going to divide it into per frame, with it being 1.325 or 13.25 millimeters as opposed to 4.2, it's literally about a third of a frame. So 1/3 of a frame, and it would be at this point here. So very close, very close. In fact, almost instantaneous. In fact, almost instantaneous. In fact, almost instantaneous before it would have got to that point. So let's go back. So with this being so close to the horizon, we've got 3 frames. We've got 3 frames. We've got 3 frames.
We've got 3 frames.
Now, if this hit was 0.33 of one frame, so a third of a frame, so almost instantaneously, what would make this bounce up, this inferior mirage bounce up, and the top of these waves get to a height of just over 20, so about 21 millimeters? Well, if we know that these are moving at 0.737 per frame, then 3 frames of this would be a little over, well, just about 22 millimeters.
Don't you just love Ranty's ruler maths, everyone?
So I'm going to say that this object, almost instantaneously, just after the last frame was taken, struck the ocean right here. And then by virtue of the fact that it took 3 frames to go back up, the water splashing up at 0.737 or 7.37 millimeters per frame would have taken it 3 frames to climb up 1, 2, 3 and get to this position here, which is relative to the first position noted on Rheds' video.
It makes a person wonder how Rheds and them got to their so-called 11 frames, 15 frames, 7 frames. You know, it kept changing until they settled on 11.
Now, that's the only way, using all the calculations that I can figure out, that I can get this result. Now, I've been doing this all morning, most of the afternoon as well, and I've been trying to figure this out. The only way, like I say, this is so close to the horizon. This is so close, it's almost instantaneous. Now, by virtue of it almost touching the water, and then it taking 0.7 millimeters per frame to actually creep back up and get into this position, it has to be. This is the only way that it could have struck, actually at the perceived horizon.
Yes, perceived horizon. I like the way you say that, Ranty. So in other words, it's perceived optical from your vantage point, not actual, just perceived based on your perspective.
It struck at the perceived horizon. The whole of this object disappeared behind the inferior mirage, and then this bounced back up. And it took 22 millimeters to take it back up to this position here. And this being the first frame, as I said, you can see it slightly stretched, you can see it slightly stretched, you can see it stretched in relation to this because it doesn't match up 100%. And by virtue of something just like this explaining how this mirage, just when it gets nearer the mirage, it stretches, you can see the stretching going on between here and here. We know that stretching is happening here, which is just pushing it ever so slightly.
I wonder what your thoughts are today, Ranty, that this video that you made debunks your own argument that you punted today. Very sad, actually.
And that's the only way that I can actually make this work. I've tried every other calculation possible, but with the speed that this is traveling, the distance that it's covering, the object in relation to the water when it actually went from view behind the inferior mirage, where it went from view right here, it was almost at the perceived horizon. And by the fact that this splash reached 21 millimeters going back up, and it's traveling at 7.3 millimeters per frame, then it has to have struck right here. There's no other way that it couldn't. There's no other way that it would have worked. Whatever calculations that Rheds is going to come up with, or Slice Arcane, or anything like this, the maths don't lie.
Yep, the maths don't lie. So, you must be running around your head right now, Ranty, saying, how am I going to debunk something that I just said was sound? Very interesting. Really want to see that.
The maths don't lie. You can't get this calculation to work any other way. I'm sorry, it just doesn't work. And the only way that they're going to perhaps try and wangle something different is if they try and claim that this tiny bit of stretching that's going on here, and they might be able to wangle a millimeter or a couple of millimeters here or there. But even if they were able to do that, it's still going to place it right behind this even if they twist it, it's going to place it right down just here. But just on pure knowledge of how inferior mirages work, knowing the calculations that have been put into this, and I've spent all day doing this now, it can only have climbed up to this position on the chart at 21 millimeters.
One thing I do love about this, Ranty, is you are showing the curve not to be physical. In other words, there's no such thing as drop, just optical.
As its speed, that's its speed that it was traveling. You can see that over here. So 1 frame, 2 frame, 3 frame, 4 frame, and it's traveled 2.95 divided by 4 equals 0.737. So for 3 frames of that would be 21, and obviously that's 21 right here. So there we go. There we go. Ranty, why does it disappear? It goes behind the inferior mirage. There we go. Here's a boat behind the inferior mirage, Brenda. This is a boat that's about 90 feet tall.
What I find really funny, Ranty, is today's argument you say that nothing can be occulted.
Half of the boat is hidden behind an inferior mirage. Now, my elevation is 30 feet, and the distance is 7 miles to this boat. There should be no hidden at all.
Yep, you tell them, Ranty, there should be no hidden at all. And yet, it's hidden. By what? Optics. Very, very strange.
And if you just use geometric, I think there's 2/3 of 1 inch, 2/3 of an inch if you just use geometric. But clearly there's about 45 feet of mirage going on here, hiding the bottom of this boat. So that's where Rheds Rhetoric's capsule is. It's behind this inferior mirage, behind this blockage. The inferior mirage is an atmospheric blockage, which the Rumpus is quite happy to agree with, and a few other people, bearing in mind.
Would that mean on your standards today you'd also still agree with this, Ranty? Because it really is quite a conundrum.
Even you, Brenda, I'm sure will know that the inferior mirage isn't where the curve of the Earth is anymore. You know, that's long debunked. Isn't where the curve of the Earth is anymore. You know, that's long debunked.
Isn't where the curve of the Earth is anymore. You know, that's long debunked.
So as I say, so there's the inferior mirage. The object falls down, it falls down, it falls down. It's behind the inferior mirage. It's still falling. It hits. Goes back up. The splash is going back up, but the first parts of the splash are behind the inferior mirage, and then poof, it's there. Dead easy. Dead easy. You know this. You've seen this demonstration, not on this particular image, but on dozens of other images too, and videos that clearly demonstrate that the inferior mirage hides things at the bottom. Clearly demonstrate that the inferior mirage hides things at the bottom.
Clearly demonstrate that the inferior mirage hides things at the bottom.
Well, thank you, Ranty, for that fine rendition of explaining that it is just optical and not physical. Oh, and Ranty, before you say, "Oh, you're stupid, I am claiming that the curve is optical," yes, going to be doing a video on that in the future, trying to explain to you how refraction actually works. Anyway, let's get back to the topic of hand about the 11 frames. Okay, so you can all clearly see it's not 11 frames, it was 3 frames, and it was me simply taking out the inferior mirage, aka optical effect, the delay, the thing that was not shown, even though I had it still in my original video. So I think I've made my point really clear. Removing the optical effect to show the impact point is not removing curve. In other words, if you are claiming I did, you're actually debunking your physical curve, because you are saying that the curve is above the physical horizon. Might want to think about that next time. So please get back to me. Is an inferior mirage optical, or is it your physical curve? The physical curve you claim I took away.
Going uphill at a fairly exponential rate. So it's good stuff. Subscribe today to Flatzoid.